good afternoon, all of you. This is our sixth class on electricity, class 10th, as per cbse syllabus. This video we are sharing on behalf of Ambition Vedic classes for education purposes only. In previous class, we have seen some of the circuit diagrams and electrical symbols. These electrical symbols and diagrams are very important to represent an electrical connections in a easy manner on a paper, like we have seen in the previous class. And there were two instruments that I have introduced you in the last class that we have studied, was voltmeter and ammeter. And today, and also we have studied in a previous class what is a resistance. So resistance is nothing but opposition to the flow of a conductor. There are four factors actually that affect the resistance of a conductor. One is length of the wire or the conductor, cross section area, material and temperature. These are the four factors which changes the resistance of a material. So in today's class we are going to see ammeter and voltmeter, and we will see how these resistant combinations are used in an electrical circuit and what are their purposes. So let's start. First of all, what is an ammeter? I hope all of you remember. An ammeter is an instrument. It is an instrument, actually electrical instrument or electrical device, which is used to measure the amount of electric current flowing through an electric circuit. See, we know that what is an electric current. Electric current is nothing but the amount of electrical charges which is flowing through any given point in a conductor through a per unit time through the conductor, right? So it is very difficult to collect all these charges and measure it by hand, because the size of atoms are very small. A size of electrons, even electrons are very tiny. Atom is a size of 10 to power minus 15 meters. So we can imagine the size of an electron goes to almost minus 20 to 25 or maybe 30. Very small, even less than what I said. So this instrument basically helps us find out how much current is flowing through an electrical connection or an electrical wire. Okay, when we connect this instrument, then we find out how much is the current. Okay, then remember that it is always connected in series with an electrical circuit. Okay, we'll discuss what is an electrical connection which represents series combination. So ammeter is an instrument, electrical instrument, which is used to measure or calculate the value of a current flowing through the wire or conductor or an electrical circuit. Then it has to be always connected in series. Now when we go to the lab, you will find out that ammeter, it looks somewhat like this. So as you can see, this portion where the numbers are written is known as a dial. So this front portion where you have a needle and these values are written, this is known as a dial. Okay, there is a different mechanism which works inside it. So right now we don't have to study that. Simply by looking at the dial, we can say how much is the current. So if the needle is at 0, there is no current flowing through the circuit. If the 0 is at 1, so then it could be amperes or it could be milliamperes. So there are different actually ammeters. So one type of an ammeter is there, it measures the electric current only in amperes. And there is a different type of ammeter which measures very small current with a value of in milliamperes. Okay, but it generally looks like this, and it always has two terminals. One is this and one is this. Okay, and independent of a terminal, the value is obtained of the current flowing through the wire with the help of a dial. Okay, so then because we cannot draw this diagram every time when we look at this, when we want to show that an ammeter is present in an electrical circuit, so in order to represent an ammeter, we use this symbol. with a capital A, and the two sides, the left hand line and the right hand line, indicates the terminals which is attached in an electrical circuit. So I hope all of you are clear. This is how it looks. This is how we draw in a circuit diagram, and it is always connected in series. Okay, then a general circuit diagram looks somewhat like this. As you can see, the current always flows from the positive terminal of a cell battery here, from the positive terminal of a battery through the filament of the bulb, and then it passes through the ammeter. Okay, if you can clearly see this diagram, so here you will find out that the wire which is allowing the current to flow through it is directly connected to the ammeter, and the second terminal of the ammeter is then connected to an electrical circuit through a plug key, and finally to the negative terminal of a battery. So we have to connect this ammeter directly. Okay, that means one end of the wire, if you cut the wire, then there will be two terminals produced. So one terminal of the wire should be connected to positive and another terminal should be connected to negative. Remember, the positive side you are connecting it towards the positive, which is connected to positive terminal, and negative side of ammeter we are connecting to negative terminal. So this half basically represents negative terminal of the battery, and the upper half represents the positive terminal of a battery. So this connection, this way or this method of connecting an electrical device is known as series combination. Okay, so this is how it is connected. Every time we draw a diagram, we have to take precaution that it should be, the ammeter should exactly look like it is connected here in this present circuit. Fine. Then the second instrument is an instrument which is used to measure the potential difference. Now what is potential difference? Potential difference is nothing but amount or concentration of electrical charges present at two different points. Okay, so we have to find out what is the potential difference between the 2 points. So from the previous definition of potential difference, we found that, or we have studied that, the potential difference is always measured from two separate points. So this is point A, for example, and that is point B. So then we have to connect voltmeter from point A to a point B. Okay, but this type of a connection, you will see, it is known as a parallel combination or parallel connection. So here, an instrument which is used to measure the potential difference between any 2 points or across any 2 points in an electrical circuit is called voltmeter. So ammeter is used to measure the value of a current, and here voltmeter is used to measure the value of potential difference. Okay, because again we cannot measure the potential difference by ourselves, so we have devised or we have produced an instrument that is able to do for us. Fine. Then remember that voltmeter should always be connected in parallel. Now what does this mean, connected in parallel? We'll see. So voltmeter is used to measure the potential difference and it should be connected in parallel. This is how it looks like, exactly like we have seen right now. Ammeter, again it has one dial which will be having a needle and numbers written on the top of it, and then at the bottom you will see two terminals. Okay, so this is one terminal and that is second terminal, right? And when we connect these terminals to in an electrical circuit, it will show some deflection, or the needle will shift from one value to another value to the right. If the potential difference is very high, it will come here. Now one more thing, remember that every instrument have certain limit, the maximum value that it can measure. So if we are connecting the voltmeter to a circuit where the potential difference is very high, where the potential difference between 2 points is very high, so the needle will be stuck here, it won't be moving because it cannot measure more than that. Okay. And like we have seen in ammeter, the current is measured in one type. Ammeter measures the current in ampere, another type measures in milliampere. Similarly here, there are different types of for different values there are different voltmeter. Okay, so if we want to measure very high potential difference, this will measure in volts, which is SI unit of potential difference. And then if we want to measure a very small potential difference, generally in laptop or maybe computers, so then we have to use something called millivolt voltmeter, so that the other one will measure the potential difference in millivolts. Sometimes you will also see that this needle will never remain at zero. It will either go ahead of zero or it will remain behind the zero. So this can be actually adjusted by moving the screw. We can move this screw and fix the it to zero value. That you don't have to do. It will be done by your lab technician. Fine. And these two terminals should be connected to the 2 points between which we want to measure the value of potential difference. Again, because we cannot draw the voltmeter as it is, it will take a lot of time in an electrical while drawing an electrical circuit. So we represent it by a symbol, like exactly like ammeter, but instead of capital A, here it is V. Now the question is, how something connected in parallel looks like. Okay, so now we have to focus here. Now you see, earlier what we have done is, if we have this as an electrical circuit with ammeter, so what we have done, we have broke the wire, we cut the wire here, and then one side of the wire is connected to one terminal and the second side of the wire is connected to second terminal. This is called direct connection. Okay, but here we can see that there are 2 points, point A and point B. So if we are interested in finding what is the potential difference inside the bulb, okay, if we want to find out how much is the potential difference between the two near the two terminals of a bulb, so then what we have to do is we have to connect the terminal, one terminal of voltmeter uh, with a common point. So remember, this electrical circuit and that connection, they are both common. So when and if you see both the sides, then the electrical circuit and voltmeter, they are common. So one side is common here and second side is common here. So whenever the sides are common connected, then we say that something is connected in parallel. If not, if we don't find these kind of junctions, then we say it is connected in series, like we have seen right now in ammeter, case of an ammeter. And with the help of voltmeter, we can measure the potential difference. In this case, you will see there is a cell connected and the current is flowing through this. Okay, and when the current flows here, it also passes through the voltmeter. And we are able to measure what is the potential difference. Very little current passes through voltmeter actually. Maximum current passes through the bulb, otherwise the bulb will not glow. Fine.